Okay, so chapter 3, we're looking at, previous slide, we're looking at equations and inequalities. So I'm just going to go over a couple of examples here on the board in case it helps. So what does the chapter look like? Well, we've got a few main areas. So first of all, we're going to do some simultaneous equation work where we solve these. This can be quite similar to GCSE, so you'll be looking at elimination techniques, but then increasingly substitution. So something like this, for example, substitution would be more appropriate. Simultaneous equations can be thought of graphically, okay, where each equation or an equation and a curve represent rules, and the intersection of these satisfies both rules simultaneously. So we'll look at that as well. Inequalities is also covered, so skills here include things like factorizing quadratics, sketching, and then trying to understand regions that satisfy rules. And we'll sketch some of these ourselves. So let's just start with this one here. It's worth spending a little bit of time thinking about how many answers we might get, or how many solutions more generally. So if we have something like a linear is where the highest power of x is x to the power of 1. You're having just one value, okay? Multiple values. So multiple values, you might have encountered this before with quadratics. Quadratics can have up to 2 solutions. Notice as I say up to 2, they don't necessarily have to. Inequalities might occupy an infinitely large set of numbers. We'll talk about just very, very little bit. We'll talk about when there are no real solutions. So the regular A-level course doesn't deal with complex numbers. If you're dealing with further maths, that's something you'll find out by in year 13. And finally, we have a case here. So I could actually add a third line to this one, okay? Because if you expand that bracket out there, or you factorize the left-hand side, what you see is that they are equivalent. So if things are equivalent, we use this sign here. This is an identity sign. Okay, what that means is it means that that relationship holds true for every value of x. X can be 2 or 5 or 10. It doesn't matter. Okay, so let's just look at a couple of examples where we might have a single solution, 2 solutions, etc. So if I were to sketch these 2 straight lines here, you can tell they're straight lines because they've got an x term to the power of 1 as the highest order and a y term. If I were to sketch these 2 here, I would end up with, well, this one here would give me a graph like this. And this one here, move it to the other side. What are you going to get? You're going to get x minus 1. Okay, I would end up with a single solution. So that's what that might look like graphically. 2 solutions, well, when might that occur? A good example would be something like this. Would be a straight line here. So this is, if I put it in mx plus c form, this is y equals minus x plus 4. So that's a straight line. This one here, what's that? Well, that's actually a circle, isn't it? So that's a circle of radius root 10. Okay, which is, about 3 point something, and minus x plus 4. So it's going to look something like that. And you might end up with, they won't be quite so close to the axes as that, but you might end up with a solution here and a solution here. And in fact, that's what happens. Okay, and we could find out that algebraically, or if we drew it accurately, we could read it off as well. We tend to go down the algebraic route though for A-level. No solutions or infinitely many solutions is also a possibility. So there are no solutions for this pair. I'd encourage you to sketch them and find out why that is. So the reason why is because they're parallel. Okay, you're going to have a situation like this. So parallel lines, when you first learned that, you would have learned the idea they never meet. So there's no solution. Whereas if we use x plus y equals 1 and we double it, for example, 2x plus 2y equals 2, we effectively have the same line sitting on top of itself. So, you could argue there are infinite solutions for this. So why are we going down this path? Well, it's just important really to think about your answers and analyze your answers, because you're going to be solving lots of equations throughout. Okay, so let's recap actually solving these algebraically. Something like this one here would sort of be on the easier side. We could use an elimination technique. The calculator is very, very good. The classroom calculator is excellent at solving simultaneous equations in this form. Okay, that's how it wants you to type it in. So you could solve it with the classroom's calculator very quickly. This one over here, elimination is not really the path to go down, because we've got a mismatch of the powers and we've got slightly more complicated terms. Okay, so we'll be looking at substitution. And in general, substitutions are going to be used quite heavily to solve simultaneous equations. Those ones there will be a little bit too simple. So I'm just going to reveal this and just talk through it, but then we'll do a couple of examples on the board. So what are we doing here? Well, we want a coefficient of x or a coefficient of y to be the same. So here, what we can do is we can call this one equation 1, and we can do equation 1 multiplied by 3 to yield 9x plus 3y equals 24. Don't forget the right-hand side as well. Equation 2 can stay put. And then 3y, it means you can eliminate here. If they are different signs, they are sort of opposites. They're the other side of the number line from each other. So if you add them together, they will move towards 0 on the number line. They will cancel each other out. So if the signs are different, okay, we are going to add the equations together. 9x and 2x is 11x, 24 and 9 is 33. Okay, x equals 3, great. But that's just the x part of the coordinate. You want to find out the y part of the solution if you think about it graphically as well. We know it's on the right-hand side, but how far up or down? So what you do is you plug it into this one, or this one, or even this one. Okay, it's up to you. Try and think about which one will be fastest though. And I think that this one here is going to be the quickest, because you have just a y on its own. So you've got 3 times 3 is 9, take it away from the other side, y equals -1. Okay, make sure that you have the x and the y aspect. Over here, let's have a look at a quick example. So look at the two equations carefully, first of all, and think about how you're going to go around solving this. So the top one has x and y, not x squared, not y squared, not xy. It has just x and y. So this is the candidate for what you're going to rearrange. X equals, well, you can get that fairly quickly. So that's the way to go. Okay. Once you get your x equals, what I would recommend doing with this one here is rewriting it, but with a bracket everywhere there is an x. So what do I mean? I mean this. So x squared becomes bracket squared, plus 3xy becomes plus 3 bracket y equals 10. And then you can put your substitution in there. So into these brackets goes your substitution, 3 minus 2y, 3 minus 2y. And if you do it like that, you're far less likely to make any mistakes. Okay? So when we expand this one out, 9 minus 12y, I don't have it, so let's just do it here. So 9 minus 6 times 2, so minus 12y, plus 4y squared from the bracket squared. Now this part here, these are just 3 parts being multiplied together, so do them whichever order you prefer. I personally like doing the y part first. So I would do 3y minus 2y squared, and then I would distribute 3. So plus 9y minus 6y squared. Okay, we'll do an example on the board in a second. What you should find is it actually creates a quadratic, and this is where the calculator will save you lots of time. Okay, if you type this into your classroom's calculator, you will get your solutions for y. And then I need to know which x belongs to each y. Okay, so make clear any pairs that belong together. So let's do some examples together now, a bit more slowly. Okay, so this one here, we look at both of them first of all. What do we notice? Well, we notice that the top one seems to be a bit simpler, seems to be easier to isolate an x or a y, and then use in the other one. 4y squared plus x squared. So the 4y squared is a bit more complicated, the x seems a bit simpler. So what I'm going to do is I'm going to rearrange the top one for x, so then it's a little bit easier to expand. So let's make this one here, x equals 2 minus y. And then we're going to plug that into this one here. So rewrite everything, but with a bracket anywhere you want to put an x. Okay. Now, let's put the substitution in. So 2 minus y. Okay. This one stays the same. This needs to be expanded. So 4y squared. What are we going to do here? So minus, that's a 2. 2 squared is going to be a 4. Okay. What else are we going to have? So in fact, let's keep this one. Because we have that negative there, it might cause a bit of confusion. Let's go like this instead. So minus 4y plus y squared. Okay. And now I've kept that negative on the outside, I can distribute like this. So 4y squared minus 4 plus 4y minus y squared is 11. And clean these up a little bit. So 3y squared plus 4y minus 4, let's bring the number over as well, minus 15 equals 0. Make sure that looks like a 15. And now you're ready for your calculator to find your solution to y. So in fact, let's just reveal that. So where did we get to? We got to this step here. Right, we got to this step here. Okay, your calculator will give you these values here. Okay, and then these values go back into either equation to find the partner. Yeah, the x for the given y. I think we had, didn't we? We had x equals 2 minus y as one of the equations. So can you see that that would be the equation to use to work each of them out? Okay, let's go back. And I want you to pause the video and have a go at this one here. Notice that the y is already on its own, so it's actually ready for you to substitute straight away. Pause the video, have a go. And I will reveal in just a second. Okay, so the bracket technique, bracket y squared becomes bracket squared, everything else remains exactly the same. We work it through to become a quadratic, which we'll deal with a lot in chapter 1 and chapter 2. We get our x solutions, put your x solutions back here to quickly get your y values for each. Let's just quickly talk about easier elimination. So the calculator is the place to go for these ones here to solve them quickly. If you have your class with calculator, if you press menu, use the down arrows to go to A where it says equation/function and press the equal sign. In general, press the equal sign every time you want to move on to the next screen. It works like an enter button. Select simultaneous equation because this topic is called simultaneous equation. So number 1, how many unknowns are there? There are 2 unknowns. You don't know the x and you don't know the y, so press 2. And then you'll notice that the calculator will show you 0, well, it will show you this, it will show you 0x plus 0y equals 0. And it has this again underneath. So you simply need to put these values in here, okay? You put the value in, so I put in 1 if it's just an x, 1x. I put in a 3 and an 11, and then I do the same here. I do 4 and minus 7 and 6, pressing the equals time every time I want to go through, and I get x equals 5, y equals 2 on my calculator. Okay. If I wanted to solve it the old-fashioned way, what I would have done is I probably would have multiplied the top equation just by 4. Something like this. There's just a few stages of algebraic manipulation before. So we want to expand this one out, don't we? Okay. To get something like this, manipulate this so that it fits this format here. So minus 5x plus 3 equals minus 10. And then the calculator, again, can solve that very quickly. It can solve these quickly because these are linear. It's just x, not x squared, just x and y. Okay, this would be an example of one that's a bit more difficult. So let's do this one here on the board. Hopefully you can read this. Yeah, you should be okay. Let's just have a look. So x plus y equals 9, and the other one is x squared minus 3xy plus 2y squared. X seems to be the most simple part in the complicated expression. So I'm going to rearrange the top line so that it's x equals. So let's do x equals 9 minus y. And then let's rewrite this one. So x squared becomes bracket squared minus 3 bracket y plus 2y squared equals 0. Okay, I'm ready then to use this substitution for the x's. So what was 9 minus y? 9 minus y. Okay, cleaning up this one over here, we're going to get 81 minus 18y, don't forget this one here, plus y squared. And the middle term, we've got a couple of choices about how we want to handle this. So you could read this as a 3 if you wanted to and keep the negative and do what we did on the previous slide. This time I'm going to insert a plus sign and I'm going to multiply by minus 3 instead of 3 as I'm going. So minus 3, let's start with a number. So minus 3 times 9 is minus 27 plus 3y. And don't forget, these parts still need to be multiplied by that y at the end. So that will be minus 27y plus 3y squared. Okay, then carrying on. So that one will be done then, plus 2y squared equals 0. As you can see, it's going to take a bit of time to solve this. Okay, but now everything is in terms of y. It's clearly a quadratic. Your calculator can solve it. So calculator, menu, equation function, polynomial is what you want to click on. Polynomial degree 2. That means what's the largest indice above the x? X squared, so it's 2. You type this one in, it will give you your solutions for y. And then you take each of those, put them in to find x. So if you do all of that, you should get 9 over 2 or 4.5 or 4.5, which goes with another 9 over 2. So that's a pair, and then this here is the other pair. Where will an A-level question likely go? So one difference is perhaps they might introduce an unknown value, a constant called k. If it's earlier in the alphabet, A, B, C, K, these are numbers, unknown numbers. X, Y, Z tend to be variables. Okay, so we've got these ones here. Calculator's not going to solve this one for us because it's got an unknown. That's why we need to know how to do these techniques without a calculator, because this is what they do in exams. I will multiply the bottom one by 3, so I'll have 3x plus ky equals 8 still. The bottom one will become 3x minus 6ky equals, what do I multiply by 3? So that's 15. Okay, these are going to eliminate. So I'm going to do, what should we do? 1 minus 2. 3x, take away 3x, is gone. Ky minus 6ky is 7ky. Please watch out for the double negatives with elimination. And then I have 8 minus 15, which is minus 7. What was the actual question? So the actual question was, oh, show that x equals 3. So I've actually eliminated the wrong thing, haven't I? Think about it. If it says show that x equals 3, and I remove the x's, I can't do that. So I've just shown you how to eliminate the x's, but actually you need to redo the question, and I want you to eliminate the y's, okay? So the top line you're going to multiply by 2, essentially. And if I just clear this out of the way, there we go. That's the top line multiplied by 2, and you can eliminate that way. Right. And now that takes you up to exercise 3A and 3B. So please make sure that you are very comfortable, especially with the skill of elimination and increasingly substitution before continuing.